Okay, let's continue our topic inequalities. Let's look at these two inequalities in example 2. And you will find both of them have the highest degree equaling 2. So both of them are quadratic inequalities. For the quadratic inequalities, we need to use the steps that we summarized in section 3. So the first step is always move all the terms to the left-hand side and make the right-hand side 0. So we will get 3x squared plus 5x minus 2 is larger than or equal to 0. Then fully factorize this trinomial. So this factorization result is 3x minus 1 times x plus 2 is greater than or equal to 0. You can use the cross method or AC method to factorize this trinomial into this one. The third step here is we use the number line to show the Venn diagram. When we want to graph the Venn diagram, we need to put down the 0 points from this inequality. 1 0 is negative 2. The other 0 is 1/3. Then you will find, okay, these two 0 points divide the whole number line into 3 intervals. And we also know the factors for both of them are linear factors. That means the sign will change around each 0 point. So let's find the value in this interval to look at if this interval is a positive or negative interval. Let's plug -3 in for x. 3 times -3, -9 minus 1, -10. -3 plus 2, -1, negative times negative. This one is positive. If the sign needs to change, so this one is negative, and this one is plus again. So right now we need to look for the x values which can make this one to be larger than or equal to 0. So you will see the x value should be less than -2. And we also added an equal sign here because this inequality has the equal 0 case. That means the 0 point also fits this inequality. So this is the reason why we put an equal sign for the 0 point as well. And the other part is x is larger than, and the same as an equal sign here. Okay, we put on 1/3. So this is the solution for this quadratic inequality. Let's look at B. First step, let's move all the terms to one side and leave the right side to be 0. If you don't like this arrangement, we can rearrange the terms in our descending order. Then I factorize this trinomial. So it's x minus 3 squared is less than 0. If I draw the Venn diagram, in this case, I only have 1 0 point, which is 3. Then I can use the testing. For example, I pick up a value and plug in for x. I will see this interval shows positive sign. And this one also shows positive sign. If you look at the whole number line, you will see on the left side of number 3, all the x values can make this one to be positive. All the values on the right side of 3, if you plug in, all those values can make this one positive again. And this 3 make this one 0. Then we will see there is no x value make x minus 3 squared less than 0. Then we can draw a conclusion. No solution. We can see no solutions for this inequality. So we cannot find any x values to make this inequality true. Let's look at example 4. Oh, this is example 3. Example 3 is a little bit more complex, and this is a rational inequality. For a rational inequality, our first goal is to get rid of this denominator. It's the same as solving a rational equation. And we learned how to solve a rational equation in Unit 1 already. But the problem in an inequality is, if this bottom expression is positive, we know this property already. When you multiply both sides by a positive value, you can keep the inequality sign. But when you multiply both sides by a negative value, you need to reverse the sign. So here, we will have two cases to solve this inequality. I will put on case 1 and case 2. In case 1, let's say if the denominator 1 minus x is larger than 0. 1 minus x is larger than 0. If you solve this linear inequality, you can get to the result x is less than 1. So that means if x is less than 1, the denominator is positive value. Then I multiply both sides by the denominator. I can keep this inequality sign. Using this method, I can change the rational inequality to a linear inequality. For a linear inequality, if we have the brackets, we need to expand the brackets. Then we need to isolate the x terms from the numbers. So I will move this one to the side and the 2 to the right side. So I will get 3x plus 4x is greater than 4 minus 2. Combine the like terms. This is 7x is larger than 2. Then I divide both sides by 7. So x is larger than 2/7. But this is also the challenging point of solving an inequality. Once you get this solution, you need to remember you got this solution based on this condition. So the final solution in case 1 should be the overlapping part of these two inequalities. How can I find the overlapping part? I can use the number line to help myself. With the number line, I put on x is less than 1. Goes this way. X is larger than 2/7. Here is 2/7. This is greater than. Then for the blue part and the red part, the common part is this yellow part. Then I can draw a conclusion in case 1. So the solution in case 1 should be 2/7 less than x less than 1. You also can say the x value is between 2/7 and 1. Okay, this is case 1. Let's look at case 2. So for case 2, we say if the denominator is less than 0. If the denominator is less than 0, this one means the x value is greater than 1. If we want to cancel the denominator, which is a negative value, you multiply both sides by negative value. Need to remember, you need to flip this inequality sign. Larger than become smaller than. Smaller than 4 brackets 1 minus x. This is a linear inequality. Then we need to open the brackets and isolate the x degree term from the numbers. So it will be 3x plus 2 less than 4 minus 4x. I will move negative 4x to the side and the 2 to that side. It's exactly the same as case 1. So it will be 7x less than 2. Divide both sides by 7. I will get x equals 2/7. But need to remember, you got to the solution based on this condition. I still need to find the overlapping part. So the overlapping part on the number line is x is larger than 1. Goes that way. Less than 2/7 goes that way. Then you will see the blue part does not overlap with the green part. That means there is no x values to fit this inequality in case 2. So we say no solutions for case 2. And the final conclusion will be I combine both of these two solutions together. So x should be between 2/7 and 1, or no solutions. But for no solutions, you don't need to repeat those words again anymore. Let's just keep this one as the final solution. Okay,